Today we are gonna see the exercise which has been sent by Shivom, and this is what the exercise is all about. That write an Ethereum smart contract which can record user's public address, and we have to create basically two public methods. One is to grant the permission to another user, and then there's another public method which can check whether the user has a permission from some other user. Apart from that, there are certain rules. What it has been decided that only user calling the contract should grant the permission, and maybe few other rules are here. And apart from that, this contract to be deployed on Rig-B network. And yeah, so we have to just see how we can create the simple contract on Ethereum network. So what I have used is Remix IDE, which is browser-based IDE for Ethereum development. So here I have just created a bare minimum line of code which will serve the purpose which is been assigned, and we can obviously enhance and fine tune this functionality. So what we are doing here is we are basically storing permission list which is called allowed here, okay, which will store an address, and which is basically a mapping of an address and another address, and then the flag means two addresses and the flag it will store. Okay, now the first thing which typically we are going to do is to add a permission, means grant permission. Okay, so grant permission function will, what it will do is that the allowed I would say the mapping, right? It will store the first index as an address, and then the second index, and then the flag. So this is how it would be represented internally. This is very high level, maybe different when we really look into the Solidity code, but very high level, this is how it will look like a two-dimensional array, I would say. Okay. So what it will do is that any person who's calling this contract can add a user to in the permission list, okay, or maybe the allowed users list. So which means that user one is a calling person who's basically executing this grant permission function. Okay, so user one would be the person who's calling this grant permission function, and the user two is the user address which has been passed in the function. So what it will do is basically it will just check whether it is a address 0 or not, and then it will add this address, means this is the user. I mean basically message.sender is the user who is calling this grant permission, and this is the parameter which we have passed in the function. Okay, so this is how it will, and then it will set the flag as true, means the person who's calling this function has granted user address to perform or have some permission for certain actions, I would say. Okay, which was not mentioned in the definition, but still we are just gonna store the bare minimum information which has been expected in the basic definition, and it will return a boolean. If this function is completed, it will return true. Okay, and once we have granted this permission, we would be able to test whether the user has any entry in the allowed array, and that how we are gonna test that is the way that the user who is calling this function should be in the beneficiary list. Basically, the second part is the beneficiary, means the originator has given some privilege to this beneficiary to act something or something like that. Okay, so that is how we have basically fetched this information from this allowed data structure, and so this will only return you true if we have any entry for the calling function for this user from the original owner who has passed the privilege. Okay, so that's how we have passed this one. And so what we are gonna do is here on the this is how the compilation has resulted, and then we are gonna deploy this contract called Shiv on our local what you call JavaScript VM. Okay, so this is what is the deployment, and it has exposed basically three public functions. One is the has permission, second one is the grant permission, and then I have added another function which will revoke the permission, so that we can have another flavor of the granting the permission in this contract. So basically, this is the account who has basically deployed the contract, or maybe whenever we execute this contract in this UI, we have to just change the address. So let's say, for example, this is our base address, and this is or the function from where we are calling it. Okay, now when I am calling it, so what I have done is I have stored two addresses from my the base account list into my ID, right? Like this one. Okay, so so this is my main account, this is second account, and this is the third account. Okay, so this is the first account, which is there 0xCA3. So 0xCA3. Now when I basically has permission, I can just test it here by calling this function. Okay, so when you call it, it returns false. That means currently we are in the okay, so here we have stored this basically exposed this function. Now let's quickly check the conditions here, and whether all our functions like grant permission and has permission satisfies all these rules or not. Okay, so I'm sorry, there is a little bit background noise from here. Yeah, so we quickly see whether the rules are satisfied by these methods here. So currently my calling address is this one. Okay, and I'm basically granting permission to another address, which is this 147. Okay, so this is my 147 address. So I am actually granting permission to this address, and so yeah, so let's see what is the result of it. So it says that it is true. Okay, so now what we have done is this user has granted permission to this user. Okay, which means my data structure now has okay. So this is the entry in my data structure now, and so when I'm gonna check the permission, like which permission I have, like has permission or not. So I have to actually change my access to have it, the account change from here. So now let me switch to the other account, which is 147.1, and we'll see whether I has any permission from this address. Okay, so we copy this as permission call, and it is showing true. Okay, so same result you will be seeing here also. Okay, now let's say if I want to revoke the permission, means if this user wanted to revoke the permission from uh, the user 147, right? So what it will do is the calling user should be the original user, this one, okay, and it will revoke the permission from this user. So which means instead of granting permission, which has resulted in true, we are now revoking the permission. Yeah. Okay. So let's see what is the output of the method call. So it has resulted true. And now since we have revoked the permission, and now we will see whether the this user means now my status is, so we have revoked the permission and we have made this false. Okay, now we will see if my this user has any permission granted from this user. So for that we have to check has permission from, and we have to switch the account so that we will be validating it. So this is my user, and we are just calling it. So now it is showing us false. Okay, so I have just explained you the basic functionality of these three bare minimum functions, and so let's quickly check whether it satisfies all the rules which is also defined. So permission can be granted by any public address, which we already have seen. Only the user calling the contract can check recorded permission for its public address, which means the calling addresses or calling user is this 147. Now 147 can only check whether he has permission from any other user or not. Okay, means he can check whether he has permission from this CA35 user or not. Okay, so that is what we are able to see. If any other user tries to fetch this record, he will always get false. Okay, so that is the second one. Any user can call contract from the address to check if they got information. The Ethereum smart contract should maintain a record in the permission list. So this is our permission list basically, and contract should be exposed to public. So that is fine. This is also fine, and contract should be deployed to Ethereum Ring-P network. Now, to deploy this contract to Ring-P, basically I tried that, but I don't have a few cent ethers. So what I have done is we have actually deployed this contract on Robston instead of usage, because I had a Robston account in which I had some Ethereum. So let's deploy this quickly on. So this is a shift, and we will deploy. So now here is my MetaMask, which is connected to Robston network, and it has, one second. Let me just quickly see how many Ethereum I have in that one. I'm sorry, this view is little slow, so just bear with me. Okay, so here it is. Now, so I am on Rockstar testnet, and my account is 2. So let me switch to the account number 1. So this is my account number 1. And let me deploy this contract to Robston network. So let's deploy this. Okay, so let me confirm. Okay, so this is the contract address, and it shows it's confirmed. So we are on an Etherscan, robston.etherscan.io.
Yeah, I will come this
Okay.
next Friday, next Saturday, 19th.
Okay, so it resulted into success, and now we can
Yeah.
go to, and this is the contract address. Okay, so we can go to this contract directly, and we can see the code here. Now this code is in binary format, so if we want to publish it properly, so we have to actually verify and publish using a few steps here. Now, this is the contract address. What is the name of the contract? That's the name of the contract. What is the compiler? So we have to just validate the compiler. What do we have here? It is okay. So this is the exact version. So this is the compiler optimization no. And here we have to paste the complete string from our contract. Okay. Let me paste the string. Keep this entries blank, and yeah, let's verify this one. Okay, so yeah, so this is verified successfully. We have gotten success method, and the bytecode and ABI contract is anyway published. So once we click it, now we will see here different tabs, and we can quickly see the code here. Okay, so this is the complete code. Okay, so that's all from my end right now, and we'll try to maybe improve these functions and functionalities later, and we'll keep you posted. Thank you.